we are going to put this in our notebook on page 37. So if you want to take a minute and pause the video, this is the way we're going to set it up. So it goes on page 37 of your notebook. The title of this is Valence Electrons, Oxidation Numbers, and Ionization. So there's a few words in here that might be looking a little bit new to you. Oxidation number, it should probably be new. Ionization, remember we still see that root word in there, ion, which means that it's going to be charged or getting a charge. So then we're going to look off of this and we're going to put 4 categories: valence electrons, oxidation numbers, the main family groups, and the octet rule. So if you want to pause the video and get caught up, I'm going to go ahead and start, but you can get it, get your sheet formatted like this. All right, first thing that we're going to look at is octet rule. The octet rule is kind of what drives everything else because it is a rule, and it says that all elements need 8 valence electrons to be stable. Now, all elements are trying to be stable. They want to be stable. They do not like to be unstable. So they're looking to react, and they're looking to react in this pattern to get 8, which octet makes sense because an octagon has 8 sides. An octopus has 8 legs. So 8 and octet seem to go together really, really well. That's where it gets its name from. So what we're going to look at now is, that is the octet rule, and now we're going to look at our periodic table. So the periodic table that we colored and highlighted is on page 30 of your notebook, and just at the top of each one you can see where I have valence electrons and oxidation numbers, and that is for your family groups. Family groups go up and down. There are 18 family groups on your periodic table. Family group 1 starts with hydrogen and down. Remember, hydrogen is only in that group because it has 1 valence electron. It is not alkali metal. It just kind of sits over there because of the 1 valence electron. Hydrogen really is in a group to itself. Family group 2 is beryllium down to radium. Family groups 3 through 12 are your transition metals, and we are not going to be focused on these a whole lot because they play by a little bit of different set of rules. So we're going to skip on over. We're going to skip the tops. So we're going to look at the tops. So this is family group 1, family group 2, family group 13, 14, 15, 16, 17, and 18. So you can see that we've listed valence and oxidation at the top of each one. So as you're looking at that and filling this out as well, we're going to list those main family groups. So we have family group, this is going to be family group 1, 2, then we're going to skip to 13, 14, 15, 16, 17, and 18. And we're going to look within those groups at their valence, how many valence electrons that they have, and then we're going to look at their oxidation numbers. So family group 1 has 1 valence electron. Family group 2 has 2. Family group 3, 3. 13 is 3, 14 is 4, 15 is 5, 16 is 6, 17 is 7, and 18 is 8. So the valence electrons can be from 1 to 8. Now remember, we said that they needed 8 valence electrons to be stable. So we can go ahead and look here and we say, oh, well, this group must be stable, and it is. That's our noble gases that start with helium. Helium, neon, argon, krypton, xenon, and radon are in family group 18. So the oxidation number is something that kind of complements this. It goes alongside. It tells us what this is going to do to get to 8. So it tells me what this element or group elements in this family group are going to do to get to 8. So this family group 1 has 1 valence electron. So we have to think about this in reference to the number 8. So if I have 1 valence electron and I need to get to 8, I have a decision to make. I can either go out and find 7 more electrons, or I can let this one go and I can drop down an energy level. If I let this one go and drop down an energy level, I'm now stable because my energy level before I added that one is full. So I do have 8 at the energy level before there. So if you think about that and you think about that decision to make, it's a lot easier to let that one go, and that's exactly what's going to happen. And when they let go of an electron, they become positively charged, and they're letting one electron go. So it's going to have a positive 1 charge. Same thing here for family group 2. They have 2 valence electrons. So in order to get to 8, they would have to either let these 2 go and drop down an energy level, or they would have to go out and find 6. It takes less energy and it's easier just to let those 2 go. So a positive making a cation lets those 2 go. Same thing. If it has 3, it's easier to let those 3 go than to go out and get 5. When you get here, this one is normally notated because it's halfway full, that it can either give or it can gain 4 electrons. Now, normally what really happens here is these guys in this family, these elements, will covalently bond, and they really won't give or take. They'll just share electrons. But it's noted as that it can possibly give away 4, or it can possibly take 4 to get to its 8. So if we look here, we're over halfway full now. So if the element is in family group 15, then it has 5 valence electrons. So it's over halfway full. So it is really, really eager to get full, and it doesn't want to let those go. It wants to hang on to those. So what's going to happen is it is going to have a -3 charge, meaning negative means it's gaining electrons, and 3 is how many it needs to get to be stable. So it's going to gain 3 electrons to become stable, and it'll have its 8. Same thing here, family group 16 has 6. So in order to get 8, it needs to gain 2. It doesn't want to let go of its 6 because it's over halfway full. When I'm in 17, they have 7. So everything in there wants to gain 1 electron so that it will get to 8. And then 8, family group 18 has 8, so what you need to do, or what you need to know, is that oxidation number is 0, meaning it is not going to gain, it's not going to lose, because it is already stable. So if an element has 8, it is non-reactive. Remember, this is also called inert. Those are our noble gases. If it doesn't have 8, then it will react to get to 8. That is the rule. So we're going to do a couple of these examples in just a minute, but let's look up here. Oxidation numbers. Remember, that's the number that tells the ionization. It tells that ionization number. So the thing is here is to tell the ionization number, it tells what's going to happen to it. If it's going to gain or if it's going to lose. So if it's a positive ionization or oxidation number, it says that it's going to gain, nope, I lied to you, it's going to lose electrons. It's going to lose electrons, and that is going to become a cation, right? We call those cations. If it has a negative oxidation number, that's when it's going to gain your electrons, and it's going to become an anion. All right, so that charge tells what's going to happen to the valence electrons, or what this element is going to do. Once it actually loses or gains them, then the element becomes charged, and that's when we call its ionization. So there's just a little bit of difference. Oxidation number is kind of before it happens, what it has and what it's going to do with it. So if it's a positive 3, it means it's going to give away 3 electrons. The ionization charge of a positive 3 means that it has bonded and has given away 3 electrons. And remember, we talked about this before we started, but this is review. Your valence electrons are your electrons in the outermost shell. And when I say shell, I mean your energy level or orbital, sometimes they're called. And these are the ones that are responsible for reacting. When I say reacting, I also mean bonding. So if they're reactive and they bond, it's based on those valence electrons and how. All right, let's do a few examples before I get out of here today, before we get done. So let's look at, let's say we have something like sodium. Sodium has a +1 charge because it's in family 1, meaning it has an oxidation that it will lose an electron. So if I look at sodium, it has 1 valence electron right here. Sodium is going to easily bond with something from family group 17, like chlorine. Chlorine has a -1 charge, meaning chlorine has 7 valence electrons, and it has space for 1 more. It has a -1 charge, meaning that or has a -1 oxidation, meaning it needs to gain an electron to be stable, where sodium needs to lose an electron to be stable. So sodium has 1 in its outer shell that it is eagerly willing to transfer into the chlorine. When that happens, this sodium does become +1 charged because it's lost an electron. Chlorine becomes -1 charged because it has gained an extra electron. And then those two things are oppositely charged, so they are going to attract each other, and those are going to make what we call sodium chloride. So sodium chloride is a very common compound called table salt. So that is just one example. If I look at another example, let's take magnesium. For example, magnesium is in family group 2. It has 2 valence electrons, and it will easily bond with oxygen from family group 16 that has 6 valence electrons. Because oxygen has 16 and it needs 8, it has 2 spots. Magnesium, if it could get rid of those 2, it would be stable. It could drop down in energy level. And that's exactly what's going to happen. Magnesium is going to take those 2 electrons and they're going to give them to oxygen. So magnesium does now have a +2 charge because it lost 2 electrons. It dropped down in energy level and it's stable. Oxygen has gained 2 electrons. It is now full because it had 6. It gained those 2. It now has 8. And because they're negatively and positively charged, they're going to attract each other. And this is known as magnesium oxide. Once it bonds, the metal goes first, because it's always a metal and a nonmetal. The nonmetal goes second, and the ending always changes to end with an IDE. So oxygen becomes oxide, chlorine becomes chloride. And that is about it. I'm going to put this up here too. I don't know if here's some practice problems if you want to think about these. I want you to try and figure out which or what element will fill in this, and there's more than one possible answer here. So anything, if I think about this, fluorine has a -1 oxidation number, so it needs to bond with something with a +1 oxidation number, and it needs to be a metal. Do not put hydrogen in there because hydrogen is not a metal, but it needs to be a metal that would bond with fluorine and become something fluoride. So something from family group 1 would fit in here, and there's many choices that you can put in there to make those stable. So I'm going to have you do this and put it on a little sheet of paper and bring it to Miss Polk at the end of class. Okay? Then when you get done with that, Miss Polk will have you finish up your notebooks and your notebook right here. After you take notes today, you're going to complete on pages 38, 39 of your notebook the notes from yesterday. Remember, you can use your textbook, page 154, 155. And then if you haven't completed your notebook, page 34, it was a sheet that looks like this. Let me find it in my notebook real quick. It looked like this. Which atom is which? This is page 34. And we started on the inside here, filling these out. so you can work on this. We did about 4 or 5 of those together in class, so if you need to finish working on that, you can use the rest of the class period to finish up, getting your notebook together. All right, have a good day, and I will see you tomorrow.